welcome back to Engage New York, Module 4, Lesson 21. Please tell me you already went through the process and you already solved all the problems, and now you're just checking your work, right? All right. So this one was already done for you. 1/4 times 1 is the same as 1/4 times 3 over 3 is 3/12. 3/4 times 1 is the same as 3 over 3/4 times, and they gave us the fraction 21 over 28. So what did I have to multiply by? 7 over 7, right? Then we have 7/4 times 1, but over here they gave us 35/20. So what did I have to multiply by in order to make that sentence true? I had to multiply by 5 over 5. So when it says you use words to compare the size of the product to the size of the first factor. So I wrote the answer in each problem is being multiplied by 1 or a fraction equal to 1. So in each problem, the new answer is equivalent to the first. But in the first one, this becomes 3 times bigger, this one becomes 7 times bigger, and this becomes 5 times bigger, right? All right, let's look at our expressing each fraction as an equivalent decimal. 25 over 100 is 25 hundredths. 75 hundredths, 2 tenths, 8 tenths, 5 hundredths, 1 and 35 hundredths, 1 and 75 hundredths, 1 and 6 tenths, 96 hundredths, 1 and 86 hundredths, 2 and 24 hundredths, 3 and 62 hundredths. How'd you do? Hopefully that you were able to do that well. Okay, on the back for the problem set, Jack said that if you take a number and multiply it by a fraction, the product will always be smaller than what you started with. Is he correct? Why or why not? And then explain. When it says explain, it means use your words and give at least 2 examples to support your thinking. So 3 times 2 over 2 is 6 over 2, which is equal to 3. So what did he say? If you take a number and multiply it by a fraction, the product will always be smaller? Always? In order for it to be smaller, you'd have to multiply by a fraction less than 1, right? Then 3 times 4 over 4 is 12/4, which is equal to 3. So Jack is right some of the time, but not always. If you multiply by a fraction that is equal to 1, the product will actually just be equivalent. So it's not, sometimes it'll be smaller, but the fraction has to be smaller than 1. Right? Because it's like, what is 1/2 of 3? Well, 1/2 of 3 is 1.5. All right. There's an infinite number of ways to represent 1 on the number line. In the space below, write at least 4 expressions, but I solved it all the way out, multiplying by 1. So 8 times 1 over 1 is equal to 8 over 1 is equal to 8. 12 times 2 over 2 is the same as 24 over 2, which is equal to 12. So notice I'm multiplying by 1 in a different way, right? 5 times 10 over 10, 100 times 1 over 100, 10,000 over 100 is 100, right? Okay. So moving on. Maria multiplied by 1 to rename 1/4 as hundredths. She made factor pairs equal to 10. Use her method to change 1/8 to an equivalent decimal. So I went, okay, so she did 1/4 is equal to 1/2 over 2 times 2 times 5 times 5 times 5 times 5. So I multiplied that, she multiplied this out. So I copied what she did, but I added an extra 2 here and I added an extra 5 here. And I pulled this all the way out. So 2 times 3. Hold on, it should be 2 times 5. I made a mistake in what I was doing here. All right. So 2 times 5 times 2 times 5 times 2 times 5 will give us 125 over 1,000, which is going to give us 0.125. If you did exactly the same thing, you would have ended up with the exact same number. But so I wanted to do something that gave us a number that was close to, but we just stepped it up a notch. Paolo renamed 1/8 as a decimal too. He knows the decimal equal to 1/4, and he knows that 1/8 is half as much as 1/4. Can you use his ideas to show another way to find the decimal equal to 1/8? So 1/4 is equal to 0.25, which is the same as 0.250, which is the same as 250 thousandths. So 1/8 is half of 1/4, so half of 250 thousandths is 125 thousandths. So 1/8 is equal to 0.125. I don't really like this problem, but I did it anyway, and it just experience. Can you take an idea and run with it yourself? All right, that'll be it for our problem set debrief. Hopefully you did very well. And if you didn't, stop the video, go back and look to see the way I solved it and the difference in between the way you solved it and I solved it. Maybe you like your way better.